Hello everyone. What you're looking at is probably one of the first limits you'll see when you start studying the calculus of trigonometric functions. The limit of x equals 0 sine x over x. Why? Because you need to know what this is to prove what the derivative of sine x is. Derivative of sine x is cosine, of course, but you need this as part of the proof. I don't think this is quite all that intuitive. I kind of thought the limit of sine x over x was 0 at one time. Well, I was wrong. We're going to study it today and see if we can figure out what it really is. This is the unit circle. Okay, radius of 1. Let's add some lines. Let's add a diameter to it. Let's put in some arbitrary angle. Let's drop a line from this point straight down, and let's put a tangent line here straight up to our angle line. Now let's label some things. Let's label this A, this B, this C, D, and E, and let's call the angle X. All right, you probably notice ABD is a right triangle. ACD is a sector of the entire circle, and ACE is another right triangle. ABD being the smallest, the sector being in the middle, and ACE having the greatest area. Now, what is the area of ABD? Well, you probably notice, since this is a unit circle, the coordinates of this point here, D, is cosine x, comma sine x. This distance here is cosine x, and that's sine x, which is the base and the height of the triangle. So 1/2 base times height, that would mean the area would have to be sine x cosine x over 2. Let's take a look at the big triangle now, ACE. Well, this time the base is 1. What is CE? What's the definition of tan of x? Opposite over adjacent, and adjacent is 1. So this distance here is always tan of x. So the area of this triangle is 1/2 times 1 times tan of x, which could be written as tan x over 2. That brings us to the sector of ADC. What is its area? Well, let's put in some values for x, some different angles, and put them into a little table here. If x were the entire 360 degrees, the whole circle, which is 2 pi in radian talk, what would be the area of a unit circle with a radius 1? The area would be pi. What if x were half a circle, 180 degrees, which is in radian talk a pi? The area of half of the circle would be half of that, it would be pi over 2. And the same thing if we made x 90 degrees, which is pi over 2, the area of 1/4 of the whole circle would be pi over 4. That kind of tells us that if you ever want the area of a sector of the unit circle, just simply take the angle and divide by 2. Just like that. So the area of the triangle ADB is less than the sector, and it's less than the area of the large one. Putting together all the formulas we found, you'd get this. That looks nice. Can we simplify it? Well, we can certainly get rid of all the 2's by multiplying by 2. We also can divide by sine. That'll get rid of this. Put a sine in the bottom. And you know that tan is sine over cosine. We're going to cancel the sine. This leaves you with 1 over cosine. You'll get this. Okay, now this is kind of looking like what we want. Unfortunately, it's upside down, but that's okay. This will still help us. Let's take the limit of all 3 expressions. Now, what is the limit of cosine x as x goes to 0? Well, it's defined at that point, and it's continuous at that point. So the limit of x goes to 0 of cosine x, that's just 1. The limit of the reciprocal is also 1. So we got this thing trapped between 1 and 1. That's nice. Now you might say, well, that's not what we wanted. We wanted the sine x over x. Yet if this limit is going to 1, its reciprocal is also going to 1. So we proved that the limit as x goes to 0 of sine x over x is equal to 1. That was nice.